Alright, this is our next MCA lesson for 7th grade, and today we're talking slope of a line. As I told the students, this is more so an 8th grade topic and something we're going to see more in 8th grade and algebra type things, but this is the basis or the basics of figuring out the slope of a line. So we're not getting into it too much, but it is something that might come up on their MCA test. So I thought it would be a good opportunity to introduce it. Alright, so basically when we're talking about the slope of a line, we're talking about the steepness of a line. Alright, so the definition is, the slope of a line is the ratio of the rise to the run between any 2 points on the line. So we can say slope equals rise over run. And that's going to make sense in a second. But these two graphs here illustrate the rise and run of two lines. Okay? So this is what we would call an uphill slope. We read left to right, and if we're going up from left to right, that's an uphill slope. And if we're going down from left to right, it's a downhill slope. Okay? So what we would say is it's the rise and run between any 2 points. So we have a point here and a point here. They have to be on the line. What we do is we count how far we have to run or go over until we're directly beneath the other point. And that's our run. And we fill that number in where it says run. And then from there, how far do we go up to reach that other point? That's our rise. That number goes here in the rise spot. So we end up getting a fraction or a whole number depending on if it reduces to a whole number or not. Okay? The same thing is true for a downhill slope, except for we're going to find out that these are a little different because so to actually finish that statement, downhill lines have a negative slope, okay? So that's the reason why they're a little different. And the reason they have a negative slope is because, if you look at it, we call this the rise, where over here we ran over and we rose up. But this one we run over and we go down. And that's the opposite direction of rising. Rising is up and not down. So if we're ever moving down, it's a negative slope. Or if you just recognize that you have a downhill slope, it's going to be a negative slope. Okay? So, yeah, obviously the one I was pointing at, this downhill one, that's got a negative slope. This one would have a positive slope. Okay, so let's actually put in some numbers here and see how this actually works. Okay. Where's my other marker? It's over here. We've got two graphs here. They're both positive slopes. And before we do anything, we notice that the right slope is definitely steeper than the one on the left. And I'll show you how we can see that with the numbers too. But first thing, you have to choose 2 points on your line. Looks like they chose this point and this point. And remember, it can be any 2 points that you want to choose. So how far do I have to move over to get directly beneath this one? Let's check. 1, 2, 3, 4. So they had to run 4. So they put a 4 here. And then from there, how much do we move up? 1, 2. So they're going to rise of 2. 2 over 4 reduces to 1/2. So the slope of that line is 1/2. Okay? And then we can use these numbers to determine the steepness as well. And we'll do that when we compare it to the other one here. This next one, a steeper line, they have a point here and a point here that they're using. It looks like to go over and get beneath this one, we go 1, 2. That's a run of 2. And then we have to go up 1, 2, 3, 4. So that's a run or a rise of 4. Okay? Now that says 4 over 2 or 4 divided by 2, which gives us a slope of 2. Okay? So the graphs themselves show us which one's steeper, but also when we compare the slopes, the bigger number you have, the steeper that slope's going to be. So 2 is bigger than 1/2, so we should have a steeper slope for the one with the bigger number. Alright? So that's how we find it, the actual slope, using numbers and points. And we already talked about which one has the steeper one and why. Okay, a couple other ones we need to point out. Okay, so here we have a downhill slope. We should expect a negative slope for this one. And they do give us the slope here. It's -3/2, or -3/2. Let's see why. They chose this point and this point. And it is over 2, so 1, 2, and then down 3, 1, 2, 3. So over 2, down 3 is a -3/2, or -3/2 slope. So that's why we get negative there, because we're going down. Okay? Now, we have two other lines that we want to talk about. We have a horizontal line, and then after that we have to talk about the vertical line. So they chose 2 points on this horizontal line, here and here. And what they did is they found the run. How far do I have to move over to get to this point? 1, 2, 3, 4. So we ran 4, but we're not going up or down at all. We're just staying at a constant level. So the rise is 0. We're not moving up. So if the rise is 0, we get 0 over 4, and we get a slope of 0. Okay? So horizontal lines, no matter what, any horizontal line will have a slope of 0. Alright? So let's take a look at a vertical line. I'll draw a little coordinate system over here. Okay? And let's put a vertical line right here. And then let's put a point here and right here. Okay? So, let's find the slope of this thing. Slope is rise over run. Okay? If I choose this point, we're going up 2, 1, 2 to get to that point. But are we moving horizontally at all? No, we are not. So that is a run of 0. But then we run into an issue because we can never divide by 0. 2 divided by 0 is not possible. Okay? So we actually say for any vertical line, the slope is undefined or no slope. Okay? So vertical lines have no slope, or we call them undefined. Horizontal lines have a slope of 0. And what I told the students, or how to remember that, is think of trying to climb or walk on both of those slopes. Okay, if you have a horizontal slope, you can walk across that very easily. It's just a flat surface, just like the floor that I'm standing on now. Okay, I can walk across that, so that's a slope of 0. The one that we couldn't walk up, unless we were like Spider-Man or had something to help us out, would be a vertical line. That'd be like trying to walk up a wall. You can't walk up a wall unless you have something to help you, right? So that one is undefined, the one that you can't climb, okay? The one you can walk on has a slope of 0. The one that you cannot walk up has an undefined slope, alright? That's how I would try to remember those. Okay, see what time we've got. Okay, a couple things we went over in class today, which will be, it was an in-class assignment. I had them fill in 4 blanks here, and then later on they started actually figuring out the slope. But we filled in the blank with this line has a slope of, is it positive, negative, 0, or undefined. This one happened to have a negative slope because it's moving downhill, so the blank should have read negative. And just for fun, we'll do this one and then I'll be done. But let's find the slope just so that we have that extra practice on the camera here. So there's a point there, and there's a point here, a point here. I'm going to choose these two because those are the ones I have labeled. So let's figure it out. Rise over run. Okay? Should be a negative slope because I have to move down. So I move down 2, and then I have to go, so that's a negative 2, sorry, moving down, not rising. Then I have to go over 1, 2, 3, 4. Negative 2 over 4, which reduces to negative 1/2. Now the cool part about it is, I could have also chosen any 2 other points. Let's say this one and this one. I'm going to erase this. I could have chose those 2. How far do I rise? Well, I go down 1. So that's down 1 over 2. And we still get the same slope, negative 1/2. Okay? So no matter which 2 points you choose, you still get the same slope. Alright, so it doesn't matter which 2 points you go with. We're going to talk more about this tomorrow and in the future. So I'm going to leave it at that for now. Thanks.